Hello everyone, welcome to my channel. In this video, I will explain about getting lost example. So this concept belongs to machine learning subject. So let us see the example related to getting lost example. So a person is lost in a city and wants to find a hostel. Different paths are tried to reach the destination. While moving from one place to another, there is no reward. Okay, so what is the main intention of this one? In the getting lost example, let us see one sample or real time example. A person, okay, is lost in a city and he wants to find a hostel. Okay, so what is going to be happened? He lost in a city and he wants to find a hostel. Different paths are tried to reach the destination. Okay, so from his place to hostel, he wants to reach his hostel. He tried different paths. Okay, while moving from one place to another, there is no reward. So if at all, when he reached a destination, he may get a reward. But when he goes to different paths, he may not get any rewards until he gets the final destination. The reward is received only when the hostel is found. So when he found the hostel, he is going to get the reward. Over time, the correct path is learned by remembering good paths and avoid wrong ones. This process is called learning through trial and error. One of the most important point. So when you say the reward, so reward is received by when the hostel is found. So when he is in some place, his hostel might be far away from his location. He is going to try it in different locations. When he found the hostel only, we can give some rewards. Over time, the correct path is learned from remembering good paths. So what is going to be happen? After he found the path, he is going to remember that path and avoid wrong ones. So let us say he tried 6 different paths, but he received only 2 paths in his hostel. Then what is going to be happen? He is going to remember those 2 lines and he ignored rest of the 4. So this process is called learning through trial and error. So let us see one example. So the person, there are completely 6 paths are there: A, B, C, D, E, F. So the person is here. So he is at the location called as E. The location called as A. Now he should reach this place. Okay. So the place A, place B, place C, place D, place E, place F. A is connected to B, B is connected to C, B is connected to D, D is connected to B, C, E, and C is connected to B, D, F, and E is connected to D, F. So you see map of places showing paths to reach F, and each circle A, B, C, D, E, place is equal to state. So this A, B, C, D, E, F, these are called as states, and lines are called as walking. So if E wants to reach F, so he may go to this path A to B, B to C, C to F. So these are called as walking lines. So he may go to this line also. The second line could be something like he can select this path 1 AB, BD, E and F. So this is called as a second path. So here you observe start from any place. So this is not mandatory like we can always start from A. But imagine just we started from here. But we can also start from any path. Okay. So we can start from any place like A and move step by step. So we are going to move here step by step. Next, the path is A to B, B to C, C to D, E to F. So reaching F is good and other moves are no reward. So when you go to A to B, B to C, C to F. So A to B is no reward, B to C is no reward, but he went to F, so he may get the reward. So this is called as what we say trial and error method. Okay. Next, we see a person thinks the hostel is at F. Okay. So in the above there are 6 steps are there. A person thinks he is hostel at F. So a rule is made, staying in the same place. Suppose he wants to start from A. Suppose he is in A place only. We may get bad. So that value could be -5. Moving for other place. So let us say A want to F. E may go to A to B. So at the time also no value. No, that is called as no reward. The value could be 0. But when he reach the F, he may get a big reward. The value is, we can say, this is called as a chips. Okay. Suppose he is staying at same place, that is bad. The value is -5. Go to another place, no reward. But he is reached destination, that is called as biggest reward. This is also called as chips. Okay. Now you observe, this is a state action reward matrix. So remember I told, so he starts from A and his destination is F. Okay. So when he start from A, when he is in A only, he starts from A, he is in A only, the value is -5. So you observe here, staying at same place. When he starts from if he starts B, if he is same at B, this is called as -5. If he starts C, he is in same location C, this is also called as -5. If he starts D, he is in D location only, -5. If he starts E, if he is in same location, this is called as -5. Okay. Now if you go to A to B, yes, if we go to A to B, the answer is 0 because moving another place. So if we go to A to B, the answer is 0. A to C. So you observe here we have only one line. So the line is here, we can observe on the screen. Okay. Now you see, so there is a, why we receive here this dash, because there is no connection between A to C, A to D, A to E, A to F. You observe here the connection is A with only B. So that's why we have written as all dashes. Now you see what is the value of B of A? B of A is 0, B of C is 0, B of D is 0. So B is connected with A, C, D. So you see B is connected with A, C, D. So B may go to A, B may go to C, B may go to D. So moving to other location, that is called as 0. Okay. So remaining, there is no connection with B, E and F. So similarly C. So when we have C, C to B is 0 because there is a connection. C to C, there is no connection but staying at same place, this is -5. Remember all of you, C to F. So you see, when you reach the definition, please remember, when you reach the definition, that is called as, we may get the result 100%. This is called as 100. So similarly D. So D is getting 2 places as 0. B, C, because this D is having connection with this value. D is connected with B, C, E. So D is connected with B, C, E. So this is the way to construct state action reward matrix. So similarly we can also do F, E and F. So remember for E we may get F. So there are 2 ways, there are only 200 values, E to C to F and E to F. You observe here C to F and E to F. So these are called as 2 values because we are going to reach the destination safely. So this is about the F. So F is only connected with C as well as E. So we may not say F is F because there is a nothing is there. When you at same location, we may not say anything, but this is a destination. That's why we are not taking -5. So this -5, -5, -5 is nothing but we are going to at the same location. But is a destination file, nothing meaning is there. So this is called as state action reward matrix. So you also observe same thing about for this diagram. So what is going to be happen? If I start from this A, so I can go to B, okay, or else I can come B to A. So this is called as the action values are 0, 0. But when I say B to C, so again we may have two values. So for B, C to B 0, for B to C this is 0, for C to D 0, 0. So this is called as what we say the values are state action matrix. This is called as a graph. Okay, how we receive this 0, 0? Because when you starts from A, if you go to B, this is called as value 0 because we are not reaching the destination. But if you observe E, I reach the destination F, this is called as 100. So for C, I can reach the destination 100. But if you see, if I start from F, okay, if I start from F, so if I go to E 0, if I start from F, if I go to C, this is also 0. So remember, when you reach the destination, we may get 100, 100. Okay, we'll move forward. So we'll see next one is the state and action spaces. So what is the meaning of state and action spaces? A reinforcement learning agent works like a search process that tries different states and actions to find the best solution. So here we are trying with the different states and actions. Now you observe all possible situations from the state and action state space and all possible actions from the action space. If these spaces are very large, the problem is become very difficult. So reduce them by helping in faster learning. So what is going to be happen when you find the solution? If there is a very large, the problem becomes difficult. If the problem spaces are very large, then the problem will become very difficult. So we need to reduce by helping them in the faster learning. Okay, so in this next concept is reward function. So the agent learns using a reward function which gives positive rewards for the good actions and negative rewards for the bad actions. So when you do some good thing, so which gives the positive reward for the good actions, negative reward for the bad actions. So remember, good actions will be remembered, bad actions will be ignored. Reaching the goal is a positive reward, while staying ideal gives a penalty. Okay, so when you stay at same place, this gives the penalty. So we discussed already, the value is -5. This helps the agent learn to choose better actions over time. So next one is the discounting. So to handle futures uncertainty, discounting will use. So total expected reward is this formula. RT is equal to RT plus 1 plus gamma, RT plus 2 and so on. Okay, so here what is the meaning of RT? RT is total reward from now, and RT1 plus RT2, these are called as future rewards, and R is the discount factor between 0 and 1. So now we'll see the agent selection. So how to select the agent? The agent calculates the Q of S comma A. How good is to take the action A in state S. So based on this, it selects the actions using. So there are 3 methods are there in order to choose the agents. So first one is the greedy, and second one is the e-greedy, third one is the soft max. When I say greedy, we'll choose the best action. E-greedy, it is choose the best plus sometimes explore. So last one is the soft max. This is chosen based on the penalty. Okay. So finally, the agent learns a policy which is called as pi, which is the best rule to select the options in each state to maximize the rewards. So what is going to be happened? Finally, agent learns a policy. Okay, what is that one? Which is the best rule. So always it selects the best rule to select the actions in each state to maximize the rewards. So always we need to maximize the rewards. So this is all about the concept called as getting lost example. Thank you for watching this video. Please subscribe my channel. Thank you one and all.